Hey, geometry. Here today to go over some of the problems from this worksheet. So find that worksheet in your packet of problems that I sent home with you, most of you, or print it out from if I sent it to you by email after the fact. We are going to do two of these problems together, and then I'm going to leave you to finish it. All right, so I've set up for myself kind of like a board here at my house. We're going to start with problem 2 because I'm pretty sure that question 1 was one of the examples in the notes already. It was like the exact same numbers and parts were given. So you can look back in your notes and find that same problem and just copy it on there, okay? But question 2, basically we're trying to solve a right triangle here, given certain parts and wanting to find other parts. Okay, so this is probably the last lesson that I'm going to send you on the topic of SOHCAHTOA or trigonometry, right? SOHCAHTOA stands for the trig functions. And just to review, really important memory device, SOHCAHTOA, and I've been saying it in my videos, and hopefully you've been seeing it in various places now and starting to internalize that just by repetition and using it. But the S stands for sine, O stands for opposite, and H stands for hypotenuse. Now, you have to know that these trig functions always take on a little equation form where, it's sine of an angle equals opposite over hypotenuse. And then cosine of an angle equals adjacent over hypotenuse. I'm just going to abbreviate that one. Tangent of an angle is equal to the ratio of opposite side over adjacent side. So we're going to be using one of those trig ratios for each problem, or more, depending on how many parts of the equation we need to, how many parts of the triangle we're trying to find. So in question 2, like I said, we're going to start with question 2. It says, if lowercase a equals 6, so let's label that, that's here, 6. Lowercase a is side A. Whenever we draw these kind of right triangles, we're always going to label the angles with capital letters, and the sides that are across from those angles are going to be labeled with the equivalent lowercase letter, okay? So measure of angle B is being given to us. It's 18. So this right here is 18 degrees. And we are being asked to find the measure of side B. So this is the question, that we should find. Actually, I almost want to take it a step further and just solve the entire triangle, figure out all of the missing parts, because there are really 6 parts here. There are 3 sides and 3 angles. We know that's a 90-degree angle. There's nothing to really solve there. We know that that's 18 degrees, and we know this is 6. But what is the length of this side, and what's the length of the hypotenuse, and what would be the measure of that angle? I bet you could tell me the measure of that angle, because this is a right triangle, and we already know one of the acute angles is 18. So what is the measure of the other angle? It's 90 minus 18, which would be 72. All right, so we kind of started solving the triangle already just by thinking of that. But if we want to find the measure of angle B, we're going to focus on the angle that was given, 18, and we're going to ask ourselves, what parts do we know in relationship to that angle? We know the side that is going right into that angle, so we know the adjacent side is 6. And then this side is not the hypotenuse of the triangle. It is opposite or across the way. So I'm going to label that opposite. And now I'm going to think about which trig function would be helpful if I'm dealing with opposite and adjacent that I either know or care about. And it's really not asking me anything about hypotenuse, just opposite and adjacent. So which of these three separate, okay, let's think of them separately. So, ka, toa. Which one uses opposite and adjacent? Well, it's easy when it's right there in front of you. Tangent, right? You can pick it. The trick is for you to know to write down SOHCAHTOA or think it in your head and be able to work through it each time you do a problem. What does the SOH stand for? What does the CAH stand for? What does the TOA stand for? So you have to be able to spell it correctly, first of all. That's important. SOHCAHTOA spelling counts because these letters stand for something. So tangent equals opposite over adjacent. That's the one we're going to use for this problem because opposite and adjacent are the two things that we have in play in relationship to this angle. So I'm going to write out the tangent function goes like this. The tangent of the angle, usually they call it theta, but we're actually talking about angle B here. Whichever angle you put there is equal to opposite over adjacent. Okay, so the tan of the angle measure 18 is equal to opposite B over adjacent 6. The only thing I don't like about this problem is that the B and the 6 look alike. So you need to write them in a way that on your paper, the B and the 6 don't get mixed up. Okay, just write neatly and carefully. Okay, next, we are going to solve for B because that's what we're trying to find. So how does one isolate B when right now it's being divided by 6? You have to do an inverse operation to get B by itself, which means you're going to multiply both sides of the equation by 6. I'm going to put it right out in front there because multiplying by 6 will cancel out the dividing by 6 and leave B by itself. So B is now isolated and it is equal to 6 times the tan of 18 degrees. Now 6 times the tan of 18 degrees is just a number that I will find on the calculator. So let's enter it in. 6 times the tan of 18. Press enter. I have got an answer of, and I'm going to check my answer key, 1.949. So it's approximately 1.95. That is the length of this side. Now, the way that I drew this triangle, since it's just kind of a generic triangle, that may not look like it makes sense because 1.95 compared to 6, it's just not working out. But if this was drawn to scale, if that was actually an 18-degree angle and that was actually a 72-degree angle, then these measurements would look reasonable, okay? But we have now solved for B, so that's technically the answer to the question. Now, what if the question went a little further and it asked us to also find C? Would we have to go through using trigonometry to find C? We could, but we also at this point have another choice. We could delve back into things we've already learned before, like Pythagorean theorem. When you have two sides of a right triangle, you can just plug it into the Pythagorean theorem to find the third side. So in this case, we have A, B, C. You know, Pythagorean theorem, A squared plus B squared equals C squared. We could plug in 6 for A, and we could plug in 1.95 for B, and we could square this, add them together. Let me just do that. 6 squared plus 1.95 squared. I'm typing in to the calculator the entire expression, 6 squared plus 1.95 squared. And I get 39.8 for all of this. Equals c squared. And if I want to find c, I just take the square root of that. Square root of 39.8. And on the calculator, I'll show you what I have to do for square root. See how above the x squared, there's a little square root button? So in order to get that, I have to press second and then square root. And then I'm going to actually use a trick where you take the answer. There's a little above this minus sign, there's also a little ANS, which is answer. So second minus puts the previous answer into the square root. And I press enter. Gives me the square root of 39.8 is 6.3, approximately. So that's the other and last part of the triangle, 6.3. We have now solved the entire triangle, even though they didn't ask us to do that. They just said find B on this paper, but we solved the whole triangle by various methods. First, we solved for B using tangent. Also, we solved for A just using the concept of 180 degrees total, minus 90, minus 18, you're left with 72. And we solved for the third side using Pythagorean theorem. So that is what it means when they ask you to solve a right triangle completely. This page is just kind of focusing in on one part or another, but in the future, if you see a question that says solve the triangle, it means do this whole process, figure out all 6 parts, all 3 sides and all 3 angles. Okay, I'm going to reset my paper and do question 3 with you because it involves a little bit different kind of calculation. All right, so problem 3. The right triangle is just a generic right triangle again. But now the information given, let me label everything. We're going to stick with C being the right angle. And the other 2 angles, A and B, that's arbitrary which way you put them. But across from A would be lowercase a, and across from B would be lowercase b, and across from capital C would be lowercase c. All right. Now, in question 3, we are given if B equals 16 and the measure of angle A is 12. Find C, the hypotenuse. So let's label these parts and think about what parts do we have for SOHCAHTOA. Write it down, SOHCAH. Well, you have it right at the top of the page there. SOHCAHTOA. But the more often you write it down, the more repetitive it becomes and you remember how to spell it, and then you can use it in your head when you need it. Okay. So I'm looking at this angle and I'm thinking, okay, I want to find C. Which part is that of the O, A, or H? That would be H, the hypotenuse. Okay. And then we've been given B, which is one of the other sides. Is it the adjacent side or the opposite side? It all depends on which angle you're talking about. Well, we're talking about this angle because that's the angle that was given. This is a relative term, opposite and adjacent. So relative to this angle, this side is not opposite. It's not across the triangle. It is adjacent. It's connected. It's going right into the angle. So this would be adjacent. Therefore, with adjacent and hypotenuse as my 2 parts that are part of the equation, which trig function would be good for this problem? Adjacent, opposite, A and h. That would be cosine. That's what we're going to use here. So the cosine of the angle is equal to adjacent over hypotenuse. That's the equation. Write it down in generic terms to start with. C equals A over H. You have to know that that translates to this equation. Okay. And that the angle always goes with the cosine function. So let's plug in what we know. We know the cosine, the angle is 12 degrees. And we know the adjacent side is 16. What we are trying to find is the hypotenuse, that's C, our unknown. Okay. In this question, the unknown is at the bottom of the fraction. So we could start to undo things by using inverse operations. We could multiply both sides by C just to get rid of the fact that there is a denominator there. So why don't we do that? We'll multiply both sides by C. Okay, that cancels out the C on this side. But what it leaves us with is an equation where the variable C is still not by itself. It's now C times cosine of 12 equals 16. So we still have to do something to get C isolated or by itself. We need to now get rid of the fact that it's being multiplied by cosine of 12. So we need to divide both sides by cosine of 12. This is the algebra portion of doing a trig function problem. Now our cosine is by itself, and it is equal to 16, our C, our hypotenuse, is by itself, and it's equal to 16 over the cosine of 12. Now, I'd like to stop right here and have you notice that prior, at the beginning, we had cosine 12 equals 16 over C. Now, our new equation is C equals 16 over cosine of 12. These two equations are equivalent. When the variable is in the bottom of the fraction and you want to solve for it, you can actually take these treat this like a fraction, okay? Think about cross products. You know how you cross and multiply sometimes? The cross products can be swapped and you get an equivalent equation. So this is a little trick. You can just swap the denominator with this numerator, and now your variable is by itself. C equals 16 of cosine over 12. Okay, now it's time to plug that into the calculator, and you can do it all in one step. You're just going to take 16 divided by cosine of 12. So this is what it looks like when I enter it in the calculator. 16 divided by cosine of 12. And pressing enter, I got 16.35. 16.4 is what I'm going to write as an approximate answer. So the length of the hypotenuse is 16.4. And that's really all this question was asking us. But if we wanted to solve the rest of the triangle also, we could, using other things we know, like we could plug these two sides in for B and C of the Pythagorean theorem and solve for A. And we could also recognize that if this angle is 12 degrees, this angle must be 90 minus 12, which is 78. So basically, we can solve for all the parts. Once you get started solving for one part, you could just keep going and solve the entire triangle, if it asks you to, which did not in this case. Okay, I am going to do one more question because neither of these questions had the angle as the part that's missing, and that's slightly different to solve for. Even though the setup is the same, solving can be a little different when it's the angle that's missing. So let me set up a new page and I'll be right with you. All right, let's look at on the back of the page number 4. Number 4 gives us the information. Remember, yours is already there labeled this way. It says a, lowercase a, is 14. Lowercase b is 17. Find the measure of angle A. So really, this is our question. Find the measure of one of the acute angles. We're still going to use trig functions, but now we have 2 of the sides given in relationship to that angle, and we're going to be solving for the angle. So this is solving for an angle. Slightly different, but we're still using SOHCAHTOA. Let's think about it. What 2 parts are we looking at in relationship to the angle that we're trying to find? Are we looking at adjacent, opposite, hypotenuse? Which 2? This side, hopefully you recognize being across from the right angle, would be the hypotenuse, but we don't care about that. We haven't been told what the hypotenuse is, and we are not asked to find it. So it's not hypotenuse. We actually have the opposite side and the adjacent side that we know. So opposite and adjacent come together in the tan or tangent trig ratio. So let's write down the tangent equation. Tan of an angle equals opposite over adjacent. TOA. Now over here, I'm going to actually write in the stuff that I know. I know that the angle I'm trying to solve for is called A. And in the numerator, I'm going to put the opposite, which is 14. In the denominator, I'm going to put the adjacent, which is 17. Now, my unknown is not over here in this fraction anywhere. I can't just multiply by a number to get rid of what's happening to it or undo it so it's by itself. What's happening to A right here is that it's kind of part of the tangent function. So I have to undo the tangent function using what's called the inverse tangent function. Some people call it inverse tan, some people call it arctan. I think I'm going to use red, it will stand out a little better. Let's see. Yeah. So on both sides of the equation, I'm going to apply inverse tan, tan to the negative 1. All right. I'm kind of squeezing it in there because I didn't leave room to write it. But on this side of the equation, the inverse tan and the tan are inverse operations, so they cancel each other out. Like adding and subtracting would, or multiplying and dividing. They are inverses of each other. That leaves A by itself. So A is equal to, and there's actually no reason to have a fraction bar there. I just wrote that accidentally, but I can't erase it because it's just markers. Anyway, A is equal to the inverse tan of 14 over 17. Okay, now inverse tan is a function that I can just calculate on my calculator. Let's see, where are we? Here we go. I need to find the inverse tan function, which basically, if you can see the tan button here, look right above that. There's a little tan to the negative 1 on the printed on the calculator, which you can access by using this second button and then pressing tan. And you get inverse tan of, and I'm going to put in 14 over 17 as a fraction. 14 over divided by 17. Close the parentheses just because I feel like it. You don't really have to. but the answer comes out to be 39.4, which is an approximation. You can see the 39.5 I will write down. Now, when we think about what we just found, we found the measure of an angle, angle A. It's 39.5 degrees. It should be acute because it's the acute angle. It's one of the acute angles of a right triangle. So always double check that what you're getting here makes sense. If, remember, I've said it a couple times now, if your number doesn't make sense, perhaps your mode is wrong. On this calculator, when I press mode, I have some options. On the very top row, there is deg, rad, and grad. Radians would be bad. If radians was on for this class, when we're dealing with actual angles that we measure in degrees, we want deg to be flashing. When you're in Algebra 2 and you're dealing with other things, you will use radian mode, but not for this. So 39.5 is the measure of angle A. Now we could easily find the measure of angle B because it's the other acute angle. It's going to be complementary to angle A. So angle B would just be 90 minus 39.5. Whoops, 39.5. 90 minus 40 would be 50, so this is going to be 50.5. 50.5. And so we've now solved for the other angle as well. And you could solve for the hypotenuse just from the given information, 14 and 17. You could plug those in. A squared plus B squared equals C squared, solve for C. And you would have solved the entire triangle. Okay, I just gave you 3 more examples. Hopefully this repetitive, doing it again, and last time you did it in the context of angles of elevation and depression, but it was still the same trigonometry process. Hopefully by now it's starting to catch on and you're starting to get it. I would like you to finish this worksheet. The ladder problem at the bottom, see how it says application problem with the ladder? We already did that problem in our notes. So you could just kind of refer back to that and copy it in there again, just so you get more practice. But you're going to do numbers 5 and 6, and you're going to take a picture of your results and send it to me if you didn't see me holding up the answer in this video. All right. I hope you guys are doing well and that, we will see each other soon. It's getting late. It's Monday night, and I'm making this video for you for tomorrow at 10:15. So I hope you aren't up at 10:15 doing your geometry. Don't forget to do your ALEX work, 5 topics per week. Don't forget to go back and make up anything that you haven't done over this last 3 weeks, because the end of the quarter is coming up on April 20th. And at that point, if anything in my grade book is missing still, it is going to turn to zeros and it's going to start affecting your grade big time. It's going to plummet from any zero. If you have a string of them and they all go in at once, it's not going to be good. So when you have time, maybe over spring break, if you have nothing else to do, you can catch up, hopefully. I will be catching up on things as well, grading papers and stuff. Maybe not for you guys so much, but I'm here. If you have any questions, please just message me and I'll help you out. Okay. Have a good night. Have a good night.